Experimental verification of principle of superposition for a given simply supported beam. Now, here you could see the simply supported beam, which is made up of mild steel having Young's modulus 200 gigapascal. The total length of the beam is 1 meter. The distance between the two supports is 780 millimeter. The cross-sectional dimensions, the width of the beam is 16 millimeter and the thickness of the beam is 6 millimeter. So the beam is resting on two knife-edge supports to form a simply supported beam. Randomly, we mark some 3 points on a beam. Let this be point 1, for example, and let this be point 2, and here let it be point O. Okay, so this is point 1, and this is point 2, and this is point O. Okay, so what I'm going to do here experimentally to verify the principle of a superposition at, say, for example, how the experiment was conducted at point 1, I'm going to add a weight of 100 gram. Note down the dial gauge reading in the tabular column. Again, you add 100 gram. Note down the reading, dial gauge reading. So like this, in the incremental order of 100 gram, we add the weight at point 1. Here you measure the deflection at point O. So I call this deflection as delta 1, which means that deflection due to load at point 1. Now let us go to the next. Here you can see we are going to load the weight on the point 2 and the dial gauge reading will be noted down. So we are not changing the position of the dial gauge. The position of the dial gauge remains at O point itself. Now at point O, we have shifted the, at point 2, we have shifted the dial gauge from point 1. Now at point 2, we add weight, the incremental order of 100 gram. So add 100 gram, note down the reading, again add 100 gram, note down the dial gauge reading, enter the tabular column, the column of loading column. So I call this deflection as delta 2, that is deflection due to load at point 2. Now go to the next figure. Here this picture shows at point 1 and 2, I am going to add the weight simultaneously. For example, here we add a weight, we measure the deflection delta 1. Here we add a weight, we measure the deflection delta 2. Okay, so 100 gram here, here 100 gram. Now 100 gram on either side, on both the sides. That means 200 gram is going to act on the beam simultaneously. The dial gauge position remains the same at point O. Now we are going to measure the deflection. Now I call the deflection as delta 1, 2. Okay, delta suffix 1, 2, which means the deflection due to load applied at point 1 and point 2. So what we are trying to say or prove experimentally in the principle of superposition is delta 1, that is deflection due to load at point 1, and delta 2, deflection due to load at point 2. Sum of these two, delta 1 plus delta 2, would be equal to delta 1, 2. Delta 1, 2, which means that I'm adding 100 gram here, 100 gram here, I measure the deflection. That is nothing but delta 1, 2. Again, I'm adding 100 here, 100 here, measuring the deflection. So delta 1 plus delta 2 must be equal to delta 1, 2, delta suffix 1, 2. Okay. So these are the apparatus required. Okay. So as I told you already, length, width, and thickness of the beam. The principle of superposition simply states that on a linear elastic structure, the combined effect of several loads acting simultaneously is equal to the algebraic sum of the effects of each load acting individually. As I told you already, delta 1 plus delta 2 is equal to delta 1, 2, where delta 1 is the deflection at reference point O due to load acting on point 1, and delta 2 is the deflection at reference point O due to load acting on point 2. Delta 1, 2 is the deflection at reference point O due to load acting on point 1 and 2. Okay, simultaneously, the loads are acting simultaneously at point 1 and 2. Okay, so I have given just a diagrammatic representation. So this is at point 1, we measure the deflection at O. Then at point 2, we apply the load, we measure the deflection here. Now both the loads W1 and W2, okay, acting simultaneously, we measure the deflection reference point O. So delta 1 plus delta 2 is equal to delta 1, 2. So this is how we are going to verify it, verify the principle of superposition experimentally. Okay, so we add a weight 100 gram or 0.1 kg, note down the reading. Again, you add 100 gram, note down the reading. Again, you add 100 gram, note down the reading. So like this, the loading part, you note down the dial gauge readings. Now remove 100 gram in each and every case. Note down the reading from the bottom in the unloading column. Take the average of these two, then multiply by 0.01 in this column, 10.75 to 0.01, you will get 0.1075 millimeter. You will get the deflection in millimeter. Similarly, for delta 2, okay, that is delta 2 is a deflection due to load acting at 0.2. Similarly, you add the weight or increase the weight in the order of 100 gram or 0.1 kg. Note down the reading, unload it, find the average, then put the average in millimeter. Delta 1, 2, okay. Now 100 gram acting simultaneously at 0.1 and 2. Okay, this is the loading part, this is the unloading part, this is the average of these two, and this we have converted in millimeter. Okay, so you could see here almost deflection during loading and unloading will be same. So during here also, during unloading and loading, it will be same here also, almost. Okay, experimentally we are saying. Now, what the principle of superposition says, this is delta 1, okay, or you take this, it would be very easy to add as it's a whole number, 10.75, let us take this 10.75 delta 1 plus delta 2, for example, 13.75, whatever it is, you add these two, delta 1 plus delta 2 is equal to delta 1, 2. You can verify like this. Take any reading like third reading, for example, 35.25 delta 1 plus delta 2, 36.25. Take the third reading 71, approximately delta 1 plus delta 2 is equal to delta 1, 2. So these are the procedures. Okay, these are the procedures. So it is how we have to conduct the experiment. I will attach the video also. The same readings, whatever the readings shown in the video or entered in the tabular column. Okay, so it is observed that the principle of superposition is verified experimentally. So now you can see here at point 1, we are going to add a weight 100 gram, okay, 100 gram here, and note on the deflection here. You can see here 3 points. Randomly, we have taken 1, O, and 2, right? So 3 points we have taken. You can first we have to ensure that 0 reading in the dial gauge before loading. Okay. So 100 gram weight is added. See the deflected. See the deflection in the dial gauge. Note down the reading, the loading column. That is in the observation table for delta 1. One more 100 gram is being added. Note down in the loading column. Again, one more 100. Now, totally 300 gram load is acting on the beam. 400. 500 gram. Okay, so note down all the readings. Okay, in the loading column of the observation table delta 1. Now unload, remove 100-gram load. Note down the dial gauge readings in the unloading column from the bottom, right? So 0.5 kg, 0.4 kg, 0.3 kg, 0.21, 0.2 kg, and 0.1 kg like that from the bottom. Now we have shifted the location of the weight anchor to 0.2, whereas the position of the dial gauge remains the same. Add 100 gram, note down the dial gauge reading, enter the loading column as we done previously. The same format, but it should be entered in the different column, separate table. Okay, observation table for delta 2. Okay, now 300-gram weight is acting. (400-gram), 500-gram. While loading, you should not touch this part, weight angle. Okay, you have to add only the weight without disturbing the setup. Unload it. Now here you can see here the two weight angles at 0.1 and 0.2. Dial gauge position remains the same. Okay. On these two weight angles, we are going to add the weights simultaneously. 100-gram here at 0.1 and 100-gram at 0.2. Totally 200-gram is going to act on the beam. So 100 plus 100, 200. Note down the dial gauge reading, enter the loading column. This should be entered in the observation table for delta 1, 2. 100 plus 100, 200. So totally 400 grams is now the weight is active. Again 100 plus 100, totally 600 gram or 0.6 kg load is acting. Again 100, 100. So now totally 0.8 kg or 800 gram load is acting on the beam. Again unload it. Just to check our readings, only we are going for this unloading. Whether the dial gauge works properly or not, something like that. We can check. There would be manually handling errors also. Okay, during experiment, we are neglecting the weight of the beam as well as the weight of the angle. That's very, very important. We need to remember. So we are unloaded. Thank you. Thank you very much.